Welcome to This Explainer. Today's topic kind of messes with our most basic intuition about the physical world. Just think about this for a second. A fully loaded Boeing 777 can weigh over 650,000 pounds. I mean, that is literally heavier than some office buildings. So how on earth does a massive metal tube stay up in the sky?
Okay, let's dive into this. Because when you see a huge commercial jet just sitting there on the runway, waiting for takeoff, it really does feel like magic, right? We're looking at hundreds of thousands of pounds of material that, by all logical reasoning, should stay firmly planted right there on the tarmac. To understand how it actually lifts off, we need to break down the invisible mechanics happening all around the machine.
Well, it all starts with movement. The primary role of those massive engines hanging off the wings is to create thrust. Whether we're talking about jet turbines or propellers, their specific job is to violently pull in air, compress it, mix it with fuel, and blast it backward. That pushes the plane forward. But here's the thing, thrust alone just gives you a really fast ground vehicle. Forward motion is absolutely essential, but it isn't upward motion.
To actually move upward, we have to shift our focus to the wings. While the engines are busy propelling the airplane down the runway, air begins flowing incredibly fast around these meticulously shaped horizontal structures. The wings essentially take that forward motion and use it to create the upward force needed to finally overcome gravity.
So how exactly do the wings pull this off? As the airplane is hurtling forward, the air smashes into the leading edge of the wing. Because of the wing's very specific curve and, its angle as it slices through the atmosphere, the oncoming air is essentially caught and redirected. It gets forced downward toward the ground. And because of that aggressive downward push of the air, the plane itself is pushed upward. It is a direct cause and effect relationship. The wing shoves the air toward the ground, and in response, the air shoves the whole heavy airplane right up toward the sky.
Let's move to and see how this builds. Flight isn't just about pushing up, though. It's actually this constant, invisible tug-of-war happening in 4 different directions. On one side, lift is directly combating weight. On the other, thrust is fighting against drag. To stay up in the sky, these opposing forces have to be perfectly managed.
Let's define these forces real quick, starting with the hero of our explainer today, lift. Lift is the upward force generated primarily by the wings pushing air down, along with some key pressure differences. Basically, if your lift is greater than your weight, you're going up.
Next up is thrust. This is the forward force provided by the engines. It is the sheer muscle of the whole operation. The engine's sole job is to propel the aircraft forward with enough speed so that the wings have enough fast-moving air passing over them to actually generate that lift we just talked about.
Fighting aggressively against that lift, we have weight. Remember our initial hook about the massive size of these machines? Weight is the constant, unforgiving downward force of gravity acting on the airplane's mass. Every single ounce of fuel, every piece of cargo, and every single passenger adds to this downward pull that the lift has to overcome.
And finally, wrapping up our 4 forces, we have drag. This is the backward pull of air resistance. Think about sticking your hand out the window of a moving car on the highway. You know that heavy push backward against your palm? That is drag. The airplane has to constantly use its engine's thrust to overcome the friction and resistance of the air pushing back against its frame.
Now, what's really interesting about this slide is you can actively see this physics at play right where you are. Try this with me. Grab a small sheet of paper. Hold one edge of it right under your lips, let the rest kind of droop down, and blow hard, straight across the top. The paper rises. By blowing fast air over the top, you just altered the air pressure, creating your own little bit of lift.
So the crucial point is, an airplane wing uses a highly engineered version of that exact same trick. Real powered flight requires this specific formula: airflow, speed, and precise wing design. Aviation engineers are simply scaling up that tiny bit of lift you just made with your breath to hoist hundreds of tons into the air.
But you might be wondering, who actually decoded all of this? Well, we stand on the shoulders of historical giants here. Daniel Bernoulli studied fluid motion and pressure. Sir Isaac Newton defined the fundamental laws of motion, and then the Wright brothers took those raw theories and practically applied them to achieve actual controlled flight.
And this brilliantly illustrates Isaac Newton's specific contribution through his 3rd law of motion. Take the famous phrase, "For every action, there is an equal and opposite reaction." In aviation, the action is the wings physically shoving air downward. The reaction, the air pushes back, lifting the airplane. Alongside Newton, we have Bernoulli's principle. Daniel Bernoulli helped explain how faster-moving fluids, and remember, in physics, air acts as a fluid, can actually have lower pressure. Because of a wing's curved design, the air moving over the top travels faster than the air moving underneath. This creates a pocket of lower pressure above the wing. The higher pressure underneath naturally wants to push up into that low-pressure area, which adds significantly to our overall lift.
Now, the Wright brothers' real genius was figuring out how to balance the whole shebang. They factored in engine thrust, Bernoulli's wing curvature, Newton's reaction forces, and the absolutely crucial angle of attack, which is just how the wing tilts into the wind. Controlled flight is the ultimate balancing act of all these invisible dynamics working together.
Which brings us to our final takeaway, and it's a profound one. An airplane does not ignore gravity. It balances gravity with the physics of moving air. The next time you see a massive jet cruising overhead, you'll understand the beautiful, invisible tug-of-war that's actually holding it up. But it kind of makes you wonder, if we can master the air with this much precision, what other invisible forces are just waiting out there for us to decode them? Thanks for joining me on this explainer.